This is my newest meter. This is a Brymen BM869s. I just bought the meter from TME out of Poland. I was very happy with the price and delivery of the meter. No problems with them whatsoever. I like the meter quite a bit. I've had it for a couple of days now. So one of the things people were asking about this meter is how it compares against the Fluke. So here I have 3 Flukes. This is the Fluke 101. This is actually the meter that has survived every test I've thrown at it so far. Next to this is a Fluke 115. And to the right of that is a Fluke 87V. Currently all 4 meters are wired in parallel and attached to a 500 microvolt reference. I'm not planning on doing a review of the 4 meters, but there are some differences I thought I'd point out. I had actually been looking to buy a higher end meter. The meters I purchased for my $50 surge test were pretty much all better than any of the meters I have owned to date for a handheld meter. I thought if I do that, I'm going to get a meter that has some basic functions that I would use. One of those was AC plus DC. Fluke doesn't offer that feature on very many of their meters. The 87.5 doesn't have it. One of the nice features and why I bought this Brymen is it can actually use the 2 current inputs as a second thermocouple. The meter can then calculate the difference between the 2 thermocouple temperatures. For me, that's going to be a very useful feature to have. This meter can also read out dB. You can set it for the resistance value that you're using, and one of the nice things with this meter is it stores those settings in NVRAM. So after you get this meter set up the way that you would use it, all that information is stored in NVRAM. You turn it off, you come back to use it the next time, all those values remain. So it doesn't really matter if you're doing capacitance versus diode testing. If that's the last thing that you ran with the meter, next time you turn it on, that's the mode it's going to go into. So I'm finding that very helpful with this meter. Having so many functions, it makes it very quick for setup. So if you're using the same modes over and over again like I would tend to do, that's a very good way to make this an easier user interface. The first feature I'd like to show is the continuity test. So with the Fluke 101 running at 1 Hz, 50% right now, I'm going to slowly increase the frequency. This is 1.5. 1.9. 2.0, and you can hear the meters already skipping. I mean, this is 3 Hz here. On the 115, again 1 Hz. This is 3.2 Hz. Again, this is 1 Hz on the 87B. And this is 3.3 Hz. This is 4 Hz. And here's the new Brymen. There's 4 Hz. 5 Hz. There's 10 Hz. There's 20 Hertz. For me, the way I use the continuity test, which is basically sliding the probes across the IC pins, I do that very quickly, so you end up with roughly a 50% duty cycle. That's a very quick way for me to find shorts and other problems in a circuit board. One of the other features that people have mentioned is the hold features. Of course, the Fluke 101 doesn't have an auto hold. You can see right now I'm putting out a pulse waveform. This is plus or minus 5 volts. You can see the Fluke is putting out a negative 5 volts. And the best I can do is hit a hold. But you can see capturing this high voltage 5 volt pulse is next to impossible with this meter. We can see even with the Fluke 115 selecting the min max, the minimum is 5, average 4.9, and the max is minus 4.7. So let's increase the pulse width here and we'll see where it can actually figure this out. So this is currently a 200 millisecond pulse width. You can see it's getting very close to reading 5 volts. So we're roughly in the area where this meter could actually pick that up. You can see here the Fluke 87 has no trouble with this. Again, comes up very quickly. I'll try it with a shorter pulse. So again, this is my 2 millisecond pulse, and you can see here the meter just can't pick this up. The hold feature on the Brymen is pretty much like the 101. You push it, it holds whatever was on the screen. It's not very helpful. Again, it has the min max. By pushing REC, it does a min max function. And you can scroll through the max, the min, the average, same as the Fluke. But you notice it's still not fast enough to pick up this 2 millisecond pulse. However, it's got this crest function here. You can see right off the bat 5 volts, minus 5 volts, no problem. Meter's actually rated to pick up a 1 millisecond pulse. Currently this is a 800 microsecond pulse width. I'm just going to clear this out. You see, it comes right back in. Pretty impressive. Again, normally I would use a scope to be looking for glitches like this, but I'm impressed that the meter can even pull this out. So this next test, what I'd like to do is show you the update rate of the screen. I have an ARB, again, attached to all 4 meters. So currently I'm putting on a sawtooth. Currently it's set for every 10 seconds, and it's going from 0 to 5 volts. And I thought what I'd show here is the bar graphs. Of course, the Fluke 101 doesn't have a bar graph. You can see the Fluke meters are a little easier to read than this Brymen. From where I'm sitting, it's actually quite readable. But what I'm interested in here is the update rate. And you can see here the 115 is scaled 1 to 6 volts, the 87 is scaled 1 to 6, and the Brymen is scaled 1 to 5 volts. So the Flukes don't quite run to full scale, and the Brymen will run all the way to full scale at 5 volts. can see how smooth the Brymen is here. The Flukes are already starting to fail. This is currently 3.2 hertz. This is now 4 hertz. You can see the 115, the bar graph doesn't even come up halfway now. It's really starting to have a rough time. Brymen looks fairly smooth throughout the entire range still. Here we are at 5 hertz. The 87V is now oscillating basically between the first and the second line here. Same thing with the 115. Brymen's still showing almost full scale with this. This is currently at 10 hertz. You can just see how fast this Brymen is. It's currently looking at 39 hertz. See, the Brymen is actually aliased now. But the bar graph's definitely showing me an indication that the signal's moving. Which is kind of the whole intent of that feature. This is a 10 volt peak to peak signal, sine wave, 1 hertz currently. See, all 3 meters not really having problems with this. And this is 20 hertz right here. See, the bar graphs are all basically reading 0, except the Brymen. Very nice. Everybody's going to start going in power savings here. So it's kind of an interesting test. Here we're looking at 20 volts peak to peak at 4 hertz. It's 50% square wave. You can see the 115, the 87.5, and the Brymen all can't track this. The baby Fluke, however, will actually display some numbers. So it's trying. So the reason I'm running this test is that it's actually switching through the attenuators, so it's taking them a while to lock back in. So now what I'm going to do is select the min-max. So the max is overload, min is overload. Average it gets right. The min it's saying is minus 875. Average 0. And the plus it's saying is overload. The max on the Brymen, 5.56. Minimum is 5.88. Average 1.44. So let's try the crest. We can see 10.2 and minus 10.2. So again, crest feature on this meter, very nice. Actually, it'll give you an idea of what's going on. Other meters can't do this. For this last test here, again, I'm looking at a full rectified AC waveform. This waveform is just 60 Hertz right now, nothing special. It's actually quite common to just rectify the AC and use that signal directly to drive into your power system. You can see the Fluke 101 is reading 1.658. The 115 and the 87.5 are reading 1.7. And the Brymen is reading 3.559. You can see here this is roughly a 5 volts peak to peak signal right now. So it would have been a 10 volt peak to peak, so half of that would be 5 times 0.707. Give you roughly 3.5 volts, which is what the Brymen here is showing us. You can see with its split display though, we show the AC component only. I gotta take this that's much nicer. Should have done that before the start of the video. I've never taken that off yet. Anyway, so you can see that the Brymen here is reading 17.03. Again, with these meters you can do this calculation. You just have to look at the DC component. You take this number, square it, take the other AC component, square it, and take the square root of the two added, and you'll come up with the same number here. It's just, again, I'm carrying around this computer. It doesn't make a whole lot of sense to make these calculations with a pocket calculator. If the meter can do it, why not? Yeah. So let's take a look at the backlights here. Yeah. Of course, the Fluke 101 doesn't have a backlight. That Brymen display is very bright. So anyway, I hope that gives you a good idea of some of the differences between this new Brymen and some of the different Flukes that are available. I do like the Brymen again. I'd recommend it. I guess the last comment I have about the Brymen is a lot of people talk about how the Fluke has a lot of history. I'd never heard of Brymen until recently. I certainly heard of Fluke. I mean, a meter like this isn't going to have a lot of history. It hasn't been around very long. It's a fairly new meter. Does that mean it's any less robust? I wouldn't say so. I think the question that a lot of you might have is, I had done these tests with this generator before. This Fluke 101 survived all the tests I had put it through. I went and I tested a 87V like this and damaged it. And I damaged it, hitting it with the same levels that I hit this 101 with. And I guess the question is going to be, will the Brymen survive a hit like this? And I'm not sure what you're going to draw from that, other than to say, the Brymen is at least as robust as this 101. A lot of people like using that word safe. I'm not a big fan of that word when it comes to meters, because I think if you're using a meter like this to go out and look at line voltages, where you're playing with stuff that's, very high current, I'm not going to do it with a handheld meter, certainly. I'd be out there with a couple of poles and sticking them on the conductors, and get me some distance away from that stuff. I certainly just don't, I can't see me envisioning taking a little meter like this and hooking it up to anything like that. So for me, safety really isn't a concern with these meters. I had mentioned before, I did a little video where I did this, I built this little attenuator, and this thing is a very high impedance. It's dual directional. Something like this where you're actually limiting the current going back to the meter. It'll handle single fault failures with no problem. Actually, it was set up to handle double fault failures. If I was looking for something that was safe, I'd certainly jam something like this between me and the meter. But even that, I don't know if I'd consider it safe. And certainly a step up. But I will say, is this meter as robust as these? I mean, certainly taking it apart, it looks very good. It uses the large fuses. Fuses are rated at 1,000 volts for both ranges. Blast shields around both fuses. You know, it looks quite well built. Very large. The high voltage resistors are in the front end, are quite large. It has a couple of MOVs, you know, PTCs, the standard stuff. Very well laid out. So yeah, I'm thinking it'll probably hold up quite well. And my plan is to try to run some tests on this meter in the future here. Maybe not with this generator. I'm planning on building a newer one. I'm planning on building a new one that's actually programmable, where this generator had to be built over and over and over for each individual test. So as I up the energy levels, I had to keep redesigning this generator. So yeah, to take this generator and go back to what it was, that's not a trivial task. I'm probably just going to start over with a clean slate, learning what I've learned as far as where the meters kind of fall out at, give me a good idea on what I need to build. So we'll start there. Again, we do have the high voltage probe now, so if we do need to go up into this 13,000 volt range again, at least we have a probe that's capable of reading it now. So anyway, I hope that helps answer some of your questions about how this Brymen fits in compared to the Flukes. Later.